Hey, fourth graders, Mr. Klingen here. So today we're going to be starting a new module about area and perimeter and how to find them in rectangles. But specifically today, I'm going to be teaching you about area, okay? So part of this should be kind of a review for us, and that's okay. So area. Area is the total number of square units needed to cover a two-dimensional surface, okay? So we measure area in square units, okay? So it could be a square unit like this. This is a square inch because it measures an inch on all of its sides. Or you could measure with square centimeters. Now this is a square centimeter because it only measures a centimeter on all its sides, okay? And there's bigger measurements and smaller measurements too. But the important thing with area is we're measuring with a square unit, okay? Now, if you're doing area of a rectangle, okay, I have this Post-it note as an example, you'd want to cover it up entirely so there's no square units that are hanging over the edges. There's no gaps. They're not overlapped at all, okay? They're just perfectly touching. All right, and then you can find out how many square inches it is in this case. So this Post-it note is 1, 2, 3, 4, 5, 6, 7, 8, 9 square inches, okay? Now, you might be saying to yourself, Mr. Klingen, there's an easier way to find area, okay? And that's right. If you know the dimensions of a rectangle, then you can multiply those dimensions to find the area. So the dimension is like the length, the width, or the height of a figure. So if I know that this rectangle is 3 inches long and 3 inches wide, then I can just multiply 3 inches times 3 inches, and that'll get me my area, which is 9 square inches. And sometimes you'll see people write area like this as well. 9 inches, and then a little 2 there, that means squared, okay? So let's try this with something a little larger now. Okay, here's a larger rectangle. All right, this rectangle is 7 inches long. We can prove it, we can count out 7 inches. 1, 2, 3, 4, 5, 6, 7, and it is 3 inches wide. 1, 2, 3. So instead of just putting all my little squares here, let's see if we can figure out, using our dimensions, what would the area be? Think we have 3 rows of 7, or you could think 7 rows of 3, okay? And if you got 21 square inches, you are correct, all right? Now, because we're using some easier numbers to start, let's make it a little bit trickier. Let's say you wanted to find the area of this big rectangle, this time in square centimeters, okay? Make a prediction. Are you going to need more square inches or square centimeters to fill up this rectangle? Make a prediction right now. I hope you said square centimeters. Yeah. So this is going to be a lot larger of a number. Remember, it took 21 of these square inches to fill up this rectangle. We're going to need a lot more square centimeters to fill up this rectangle. Now, I went ahead and measured already, okay? And this rectangle in centimeters is 18 centimeters by 8 centimeters, okay? Now, this gives us another good opportunity to do a little bit of multiplication review when it comes to larger number multiplying. And we use a method called the area model for this, okay? Now, I have a website that you're going to have access to as well when you're completing today's assignment. It's called the Partial Product Finder, and this can kind of help you visualize some of that multiplication, okay? So I'm going to put in the problem that we're doing right now, which was 8 times 18, okay? So we're going to make a rectangle that's 8 by 18. There you go. Looks pretty similar to our rectangle, okay? So here's all those little centimeters filled in right there, okay? But when you're using the area model, you don't just think about it like 8 times 18. You think about it like the ones digit times the tens digit. So 8 times 10. And then you think about it like the ones digit times the one digit. So 8 times 8 in this case. Okay, so we split up our problem 8 times 18 into two different parts, 8 times 10 and then 8 times 8. Okay, so on my paper, what I would do, okay, is I'd make a rectangle. I put my ones place here, and instead of 18 up here, I'd break it into tens and ones. 10 plus 8, which would give me 18. Okay, I like to remind my students to put a line in, breaking up your two different rectangles where you have a plus sign. Put that line in there. So here, my problem here is 8 times 10. Okay, 8 times 10, that's 80. And then over here, we have this rectangle is 8 by 8. So 8 by 8 is 64. Okay, and I can even go back and check my work on the website here. Okay, if you click this little I button, you can see what the different partial products would be. Okay, so 8 times 10, that should be 80. 8 times 8, that's 64. Okay, so far so good. Now the last step you do when you're doing partial products is you add your two products, 80 plus 64. Okay, so I'm going to start in the ones place. 0 ones and 4 ones is 4 ones. Now I have 8 tens and 6 tens. That gives me 14 tens. Now if I have 10 tens, that gives me 100. Okay, so I'm going to put my 4 tens here, and I actually made 100 there. So my answer should be 144 centimeters squared. Excuse me. Excuse me, everybody. So, and there's my answer there, 144 square centimeters. Okay? So you'll have access to this tool while you're doing your work today, but I do want you to try and actually make the area model. So let's take a look at our assignment in Seesaw here. So you're watching the video lesson, okay? Once you finish up with this, you're going to click Add Response, okay? It's going to take you to this page. Here I did an example problem, 7 times 24, using the area model. I want you to try this one, 4 times 38, using the area model, okay? So you'll use the pen tool to try and solve that, okay, using the area model. Here's the link that will take you to this website if you want to try making it and seeing what it would look like, okay? Make sure you click that green check to submit your assignment once you've solved 4 times 38, okay? And then lastly, you're going to visit I Know It, and you're going to be doing some more 2-digit times 1-digit multiplication problems like this, okay? All right, happy solving, fourth graders.